So I know that there are some slides that I sent through. So yeah, so I'll let you find out while I introduce myself as well then. So good morning, everybody, and I think we had a very interesting discussion just a few moments ago there, and I'm your next engineer sitting here. But just a quick story on the GPS. I think we've seen some of these issues before, even before GPS, because I was part of conducting a test flight some years back, and we were flying radials, and all of a sudden the test aircraft did a 180-degree turn and headed back down the radial. What's going on, guys? What's going on? When we looked into it, we found that a nav aid had been moved, it had been NOTAM'd, it had been all done correctly, but they had failed to update the management system on board the aircraft. So it passed the right nav aid, no problem. Then it's planned for the next nav aid, which was now behind it. The aircraft did a 180 to go to the next nav aid. This was fortunately a test aircraft, but it was finger trouble. So it shows you that many of our technologies are still vulnerable to the human element of who programmed it, who told it what to do, etc. And I think that's a theme that will come up a number of times, is the role of the human within all of our complex systems. So just a little analogy for you for some time as we prepared the slides. But just a quick introduction to myself. I'm Peter Hotham, as introduced. I'm from the SESAR Joint Undertaking. I'm the Deputy Director of Operations and Programs, and I'm responsible for the technology aspects of the program as well as its long-term innovation content. So, coming to talk to you today, we have, as Paul said, this massive program. So, choosing really what to talk about was quite a challenge for me. I am available to you all this morning. Unfortunately, I do have to leave at lunchtime to catch a flight back to Brussels. But if you want to catch me at the break to talk about anything, please do so. But I will have to go promptly at lunchtime, so just a logistics there. So moving into my presentation, I've got 45 minutes. Don't know quite how I'm going to fill it yet. I think I've got enough slides and material, so I might be looking for a bit of interaction from you at some point. So no dropping off, or I may well hand over to the audience for a moment. Okay, so SESAR. Just a quick summary at a very high level about the challenges that SESAR is established to help resolve. And I present this deliberately from the point of view of the airspace user. Paul referred to the dire straits that an airspace user community airlines are in today. They're faced with a number of challenges. Those challenges change with their business, etc. They're never really static. And one of the important perspectives of this slide is there's not one single challenge we're targeting. It's a portfolio of challenges in order to bring benefit to airspace users. A number of those challenges are around congestion. You may say, but your capacity predictions are now much lower. Yes, overall, but the demand to go to certain key places causes us congestion issues. So we still have to resolve those congestion issues, despite the overall capacity trend. So there's a balance there: capacity, congestion, the knock-on into delay, the cost of fuel, cost of operating, the high charges that are currently made today to the airlines, and the overall complexity and risk element of performing that operation. So SESAR is looking at targeting a number of those areas. So helping relieve congestion, to reduce delays and reduce the cancellations, to allow much more optimized flight trajectories to help bring fuel efficiency and operating efficiency, to reduce the charges that are incurred by the airlines from the air navigation service providers, and to improve the overall level of automation, reducing some of those risks to safety and making the system more predictable. All things I'm sure you will agree are great to aspire to, but what are we doing about this? Now, if I went into a program of over 300 projects, we could spend all day, I guarantee you would be asleep. So we're trying to find a way of navigating through that a little bit and keeping the interest level up. So my next slide. Okay, what do we change? This is, if you like, my high-level picture. This is what aviation is today in perhaps its most simplest rudimentary form, representing all the different actors and the areas of activity. And there are also areas that SESAR makes change. So just picking a few of them, we have guidance on an airport. So we've got the airport actors over this side, military, collision avoidance between aircraft, navigation, we talked about GPS a moment ago, navigation, separation management, communication, sequencing and merging, routing on the airfield, all things that, if you think about it, can build towards helping those challenges. But we end up having to make a lot of change in a lot of places using information, clearly managed and available, and thinking about the network. What is the objectives of this network? What are we trying to achieve with it? So this just starts to show you the sort of things that we touch within SESAR. We are not a program to change everything. I'm not going to take that away and go, da-da, and this will be SESAR. No. We have to evolve from where we are today to somewhere we want to be. And we make selective changes, and those changes need to be deployed. Our program is about making change deployable. What changes do we make? When should we make them? What benefit will they bring? And what's the risk level remaining to actually get these changes into operation with the deploying organisations, be they airlines, service providers, the network manager, etc. So this just shows you the general scope of what we do. So I hope that is a slightly more accessible way of describing us than a big work breakdown structure, list of 300 projects, and just sending you all to sleep. And each time I look at that, I find something new myself, and I go, oh yes, I can talk about this. So I think it's a nice just way of summarising. And I made a note earlier, could I see a UAS in here? Because it was something that was mentioned earlier. And it doesn't exclude it. So I'm going, okay, it still works. So just stepping from this back to a little bit of practicality, realism. Here's another point I want to make. If I go back to the 1970s, one of the most infamous and regularly used aircraft at that time on long haul is Boeing 747. This is a picture of a 747 cabin from that time, cockpit from that time, containing 3 to 4 pilots and navigation crew. You can't see it, but it's full of paper, charts, books, and everything in there. They have analog electromechanical displays, very mechanical form of controlling and steering the aircraft, a VHF-HF radio, and an autopilot. So it's pretty much a manual way of operating with some support. If I compare that to today, this is the cockpit of 380. So how does it compare? 2 pilot crew, electronic displays and flight bag, so the flight bag replacing the paper charts and books. Digital head-up displays, fly-by-wire, single cockpit approach, all integrated, satellite comm, data link, collision detection and avoidance, and a flight management system. Maybe taking away some of that direct control role and putting it into the automation within the cockpit. But that's the move from the 70s to today in that environment. If I now look at the ground side, so this is the air navigation service provider part, similar time frame, 1970s. We look into a control room there. It's mostly a low light, almost dark environment with 2 to 3 air traffic controllers per position, per area of airspace. Analog displays, these nice bright orange, lovely things there. paper strips, which you see in front of them, telephone coordination, handset here, telephone panel. They've got their VHF radio for clearance to aircraft, etc. They've got a local radar feed, so they know what's going on, what aircraft are around in their area of interest, and they've created a national flow, so they know what's coming at a national level. And that's kind of where we were in the 70s. Again, moving forward into a similar time frame, if I look at a typical ATC position today, then it's a much more light environment. It's a nicer place to be, which is good for the controllers. And there are still 2 of them, sometimes 3, but about 2. They have modern digital displays, still have this paper, sometimes electronic strips, but often paper still. VHF radio clearance, that's the same. A national radar feed now, and flow management at a European level. So that's the comparison there. Now, whilst I could go into the differences between the changes on the ground and the changes in the air, and you can see that there are some, but it's generally moved forward. I think the point that I'd really like to make is we're talking about 40 years. Still, many of the technologies that were deployed and used in the 70s are still there. And they're coping with today's traffic. Only just, but they are. And they're still there. We still have a high degree of fragmentation across our systems. What that means is that the systems have a very simple interface to exchange information with each other, which means that we lack a strong interoperability between our systems, and we lack that information exchange and value that comes from information. And I'll develop on that a little bit later. We're still doing procedural-based tactical control, and really with a rather low level of automation. There's increasing levels, but it's still human-centric, very much human-centric. And this is a 40-year step. So how much change do we expect in the next 5, 10? You can see there's a challenge there about moving things forward, accelerating and enabling change to come into our environment to support airspace operators and our industries and enable economy, to facilitate some of the cost reduction, all of the things that some of our other industries from other sectors have been achieving by using technology, information, and other techniques. And we haven't really moved substantially in that area yet. And I'll point out some of those key threads later. But it's an interesting problem. Why haven't we moved as far as we could? There are some barriers there, and many times it's a safety barrier. Safety, no, we can't do that because we can't say it's safe. But you will find there are others as well. One of them may be the legal circumstances that we're in, and many others. But there are barriers there to change. If I just now take another view of SESAR, again, not describing to you 300 projects, but there are key things that we change in SESAR to try and exploit benefit and benefit more quickly. So one of the things we have, as I pointed out earlier, is not a particularly good integration. Airports are often one of those big congestion points. So the integration of an airport and exchanging information in an effective way with airports is key to enabling some of these benefits. The 4D trajectory principle, rather than having tactical management, allows us to plan a more efficient and effective operation on the day with multiple airlines, multiple operators, all with multiple demands and different constraints. So the trajectory principle is there to assist in that. The information management is key as well. This is about ensuring that we've got the right information in the right places being used by the right people in the correct way to actually make value-add decisions, the real decisions that make the service, the operation more effective. And then the one that you're particularly interested, I'm sure, automation. How we begin to give more of a role to the automation, to the system element of our architecture to enable some of these benefits to be delivered. And then finally, the working together, collaborative planning, integrating all of this together. So that's another way of seeing the scope of the SESAR program today. What this doesn't show is we also have a number of transversal, what we call transversal projects, where they don't just explore problem solving in one of these domains, but they look at, for example, the economics case, the performance, security, business cases, environmental case, safety case, etc. Those sort of things, so that when we're looking at change, how credible is it that this change can be taken on board by the environment that it's targeted to go to? How do we convince people that this is a deployable solution that will bring some real benefits? Because that's the point that the SESAR, the SJU responsibility ends, and we hand over to deploying organizations and to industry to industrialize the products that we have prototyped and trialed and validated. So that gives us the insight, the picture, and I'm just going to have a little look at a couple of these to give you a bit more of an insight. First of all, 4D trajectory. Now, the 4D trajectory is the, if you like, the end-to-end plan for what a particular flight is going to do. And at the point of executing that trajectory, it takes into account all the local constraints, including avoidance of weather, etc. So the graphic at the top there just shows all phases of flight and tactical resolution of short-term issues, but conformance to an overall plan, the overall trajectory. And today, the system is a constraining factor to that trajectory, and we need to have an ATC system that supports the trajectory. Now, this funny black thing here would be an embedded graphic, so I'll just get my acting out and just if you can imagine for me that Stockholm sits about here, Brussels sits about here, and if we were to take a flight today, we would track down the coast through Denmark. There's a military area about here, so we come round this, we head north again, down here, we come round and we come back to Brussels. That's the typical trajectory that would be flown today. In an ideal world, the ideal trajectory the aircraft and the airline would like to fly is, of course, here to here, no way, straight in. Why can't they do that? Well, because they're not planning the trajectory. Each of the responsible service providers is providing control and guidance on their segment of the flight, and they take into account the constraints at that time, including reservation of military areas, etc. So you end up with a suboptimal trajectory. Our objective is to be able to have as many aircraft operations on their optimal trajectory as possible, whilst meeting meeting all of the local constraints by planning at a network level and planning much earlier and having the system based on the trajectory rather than on the airspace itself. So if you imagine the airspace is operating, the trajectory is operating through many different parts of the airspace. So it's a more effective way of managing the traffic, and that is what a lot of the research has told us, and that's what we're now implementing and demonstrating within the program. And earlier this year there was the first initial 4D trajectory flight, which is conducted by a test aircraft from Airbus, and we learned an awful lot of information from that will then help us move forward into finalising our initial 4D proposal and then moving to our full 4D trajectory capability. So it's work in progress. So forgive me for the simple acting of what should be in that box, but just imagine that's what it would be. There's a video file that goes with this, and sometimes it doesn't run. So another area, the information management. So for this, I'd just like to draw an example for thinking about outside. You know, how many of us are walking around with one of these? Smartphone, web access, information at your fingertips, reminders. Could be a damned nuisance, but it's also invaluable in the way that we operate today, both personally and with work. You know, how many extra hours have companies got from people by them working on these in their spare time? And are you getting paid for it? Of course you're not. You're doing it because you love it. But that's happening outside of the ATM sector, the use of technology in that way, just as an example. And if I look at information technology, it has radically changed what we do, how we work. Some would argue not for the good, but it's certainly radically changed the way we operate. And it's certainly helping industry to reduce its cost, reducing time to market, and improving the overall decision making, because you're getting information you didn't have before. So why should ATM be excluded from that? Well, it shouldn't be, should it, really? I mean, it has to have something like this if it's going to deliver some of the same benefits that other industries have seen. So our simple description of what ATM will be implementing is our own intranet. It's a system-wide information management concept. It's an intranet, which means it's for the aviation community. And it's for exchanging information like the 4D trajectory with all the actors, aircraft, airline operation centres, air navigation service providers, airports, etc. It supports improved decision making, it supports enhancing the automation, it will significantly reduce our communication infrastructure costs and the inefficiencies that go with it. And another little black box here is about the communication infrastructure. And really what we have today is it's very much a point-to-point communications infrastructure. If I need to talk to you, I'll establish a connection. If I need to talk to you, I'll establish a connection. And it evolves over many years. And if you ask many service providers to tell me the cost of your private connections to other agencies who you need to talk to, they themselves get a shock how much that is actually costing them. And the first thing they then start to do is, well, I never talk to him anymore, and I'm still paying for it. Hell, get rid of that one. So it's all point to point. Increasingly, we're starting to get a network-based communication, but it's still point-to-point hierarchy. So SWIM is about ensuring that we have publish-subscribe, which is the way that other industries would operate, that we can provide information, you subscribe to it, you can enhance that information and republish. Others can then subscribe. So it's not about individual organizations talking to other individual organizations. It changed the emphasis to the information, not the communication itself. So it's really a cultural shift as well as a technological shift. So this one's very important for us. But information is now flowing much more freely. And you always get into those questions of, but it's my information. I own it, so I'm not going to give it to you. Well, we'd all benefit if you did, and then you'd benefit some more because you could then subscribe to something better. So there's always a barrier to starting this because of the fear of I'm giving something that I won't get back. And again, we get into some legal discussions as well about ownership of information, liability of information. If I publish something which then appears to be incorrect or is found to be incorrect. So all of these sort of things, which today are much clearer with our point-to-point and direct accountability, but in a network sense, it comes down to the information And how do we deal with that? There are some issues around that to be resolved. So I think coming to the core topic now, which was about automation. I'd just like to remind everybody that SESAR, the SJU current scope, it retains the human as a central role. We are not advocating taking the human out of the loop, although there are increasing demands from airspace users such as UAV operators to be operating in non-segregated airspace, which means that they are operating with controlled and managed traffic rather than in a separate designated area. And we will address that problem. We have to. SESAR is about accommodating all airspace users, so we've started some work on that today to understand how we can accommodate those kinds of users. But essentially, we are still assuming, even with the UAS, that there is a remote pilot. It's the ICAO definition of the first level of integration of unmanned air vehicles, which they're calling remotely piloted aircraft, RPA, which means there's still deemed to be a pilot in command. He's on the ground. That way, it avoids some of the issues, the legal issues, etc. But there is another step, which is the autonomous vehicle. How do we deal with that? It's really not being dealt with at the moment, certainly within the scope of the mainstream SESAR program, but we do have some activities within one of our research networks that's looking at automation. I'll come to that shortly, just to show you what is happening in some of those areas. Coming back to SESAR, our automation is about meeting those challenges that I described earlier, providing a greater level of automation support, making the computer tools much more influencing in the decision-making process, but the human is still taking the decisions. There is clearly a fundamental dependence on the information that's available to either the system or the human or both, and that's another interesting aspect, and it's something that we could have discussed a bit more on the GPS, because there's one scenario which is your GPS position and navigation instruction is presented to you, the user. There's another scenario where that information is entered into an automated control system and it acts on it. And the human has the ability to reason and say, I don't think that is quite right, I will wait. The machine, unless hard-coded to do something like that, will accept the information, process it, and make the best decision it thinks appropriate at that time. Something to bear in mind. Which brings me to human factors. Clearly, absolutely critical in delivering the right level of automation in the right places and ensuring the human is doing the right tasks and that the support are doing the right tasks. Which brings me to the next important point, which in my career has been one of the most difficult things to achieve. We have this great idea, and we know it works, and we know we can deliver the benefit with it, and then we get into what happens if. And you know, most of the time, we can create a what happens if scenario and show that we can maintain safety. But I tell you what is absolutely the killer, and that's recovering out of that situation back to where you were without stopping. Which, when the business pressure is on to keep operating and the safety pressure is on to ensure safety, the recovery steps are often the most difficult to undertake. So this one, for me, I would put up in lights, because this is, if you forget this at your peril, to be honest, you will never go anywhere unless you can effectively describe a failure mode and a recovery so that you can maintain the business continuity as well as maintaining a safety argument. So, for me, a big one. Now, I've talked a lot about information, exchanging it, supporting automation, etc. Interoperability, great. We have largely been isolated from the most severe security, IT security threats in our industry in the past because we tend to use archaic, out-of-date, bespoke protocols and interfaces that talk between closed systems, and therefore it is incredibly difficult and not very interesting for people who want to hack into and do something with your system. They don't find it a particular challenge, so we've been relatively unaffected, relatively. But if I say now, well, we're going to have open protocols, more use of commercial systems, information management available to a whole set of actors and systems, international standards for interoperability, we have to be very careful about how we deal with security. It's another concern that we have to take very seriously. It's also something that we have to take as a balance of risks, because I guarantee you that if you took the absolute view on security, we wouldn't actually have a system that's useful, that performs functionally. So it's getting the right level of security, and having that right level will always open the discussion again up to, but if it's not the right level, whose responsibility is it? Why didn't we do more? Who's liable for this? So another topic of interest, I think. So moving, I'm getting ahead of myself. Moving into a different kind of phase of my talk now. That was really all about SESAR program, what we're doing, getting to validation, the sort of content that we've got. The reason you're all here is that we also have a long-term and innovative research part of our program, which goes beyond the sorts of things that I've been describing there. And you can imagine how you can easily move beyond some of those things into the further future. And that's the role of our innovative research. And before I just dive into it and go, this is what it looks like, I just want to reflect for a few minutes on innovative and research and just ask a couple of questions. This time it's not going to. There we go. And this is a couple of slides entitled The Right to Dream. So I think many of us here, we would consider this vehicle, Concorde, as a great adventure, a great achievement. We praise the people that flew them, we praise the people who designed them, and the people that made it happen, and we all, each of us, say, oh, why didn't I ever get to fly on that? Or, I'm glad I did get to fly on that. It was, I've done it. It was the ultimate. It was a dream, and it was a dream that became a reality. But why is it held in such reverence? Why do we look to it in admiration? Well, there's a number there of key points that I'd like to make. One is it stretched the limit, it pushed the boundary. It set some challenges. It was about innovation, and I'll come back to this innovation word in a minute. It sent some positive values in its time. Perhaps today it doesn't send so many positive values for other reasons. In its day, a set of positive values, and it represented achievement. So that, for me, is starting to put some context onto innovation and innovative research. So if I move from that period in time, perhaps, to now, some of our challenges may be a bit different. If we think about the challenges in front of us right now, there's changes in population and demographics, material resources, financial resources, economic climate, energy supply, power, heat, fuel, climate change, all things that are topics for discussion today, which are a whole different set of challenges. They were not the challenges being addressed by that last dream, but now we have another set of challenges. So what do we need to do? Well, if we're going 2025 and beyond, what's the vision? Well, I'm not going to be able to show you exactly what that will look like, but I know that to engage all of you, and me as well, I'm not isolated from this, I want something that's ambitious, I want something that's challenging, engaging, relevant, and different, and I think many of you do too, which is why you would be part of this dream. And one of the things that I don't want to forget is that actually when we realize this dream, and we talked about automation earlier and autonomy, it doesn't matter how far we go in those things, we still have operators, developers, and customers. So we still have people. Even if it's a completely autonomous device, who designed it, who tested it, who built it, who bought it? So people are still playing a role, and therefore the human element really has to be taken into account whenever you're considering automation at any level. So it's just a message there. So this is our, if you like, our right to dream. This is where I think we should set our stage. And now moving into what we do in SESAR and how innovation becomes real. And it's important to talk about really what innovation is. And I hear many people say, oh, I'm involved in innovation, and they're sitting in a room somewhere on their own. I'm arguing, no, you're not involved in innovation. You might be doing something very innovative. Don't argue with that. But to actually be involved in innovation, you have to be part of a bigger picture. And in this picture up here, I've described it as a life cycle. You might be involved up here, generating ideas. What's that dream? You might be involved here, understanding how that dream might come to reality. You might be involved here, which is pre-industrial development, prototyping, understanding the potential of this idea. You might be involved here in industrializing it. You might be involved in here actually deploying it and using it in service. All of you are working potentially in an innovative way on this new idea, new way of doing things, new procedures. But the innovation is by moving through these and actually delivering something into reality. I come back to my Dream Concorde example. It was that dream because it actually flew. There aren't many of us in the UK probably that remember TSR2. It kind of flew but then got stopped. But the dream everybody lives is being associated with Concorde. So the innovation is about getting from here to here. And one of the things that I do want to add to this is when we do research, that doesn't mean to say that everything we do here has to get to here. Some of the things we do here generate knowledge. That knowledge allows some of these other phases to happen. So it's not just a one-to-one step. You do more research in some of these phases than you need to be able to get here to be able to generate the knowledge to move to the next step. But the main message on this slide is innovation is about moving all the way to here. And it's a continuum of change that's about meeting societal needs, it's about meeting the market. And you move round this all the time, exploring, applying, completing, exploiting, delivering, adapting, and with that knowledge you're also exploring some more. So it's this cycle, and it's how we keep that cycle going so that we keep our innovation level in our industry to an appropriate level, which means we have to invest appropriately in the actions in these particular areas. And that's part of what our Work Package E investment is about. It's about generating some of the ideas and applications that will become things for the future for us to develop and deploy, or generate knowledge that helps us understand how to develop or deploy. Okay, so I'll come back to my favorite picture again. But just summarizing innovation then. So innovation has three elements for me. And if you take one of those away, it disappears. So it's about what and what is desirable to the users. Will somebody buy this? Will somebody actually operate it, use it? It's also what's possible. There's no point. So Leonardo da Vinci designed the helicopter, but unfortunately he didn't have the technology possible to realize that dream. So it wasn't the innovation at that time, but it did become one later. So what is possible with technology? And then what is viable in the marketplace? Can you actually sell it? Will somebody buy? Is there a customer out there? And it's that important element there about getting it to the marketplace. And I highlight this one because this is where some of the barriers can be. You can have the perfectly desirable thing that's perfectly achievable with the technology, but there is a barrier in the marketplace to actually enable it to go live, to actually get it there. And we want to avoid this being a legal barrier, for example, because if we're going to encourage and facilitate change and innovation in our sector, we have to address those barriers before they stop the investment we've made from actually being realized in reality. So we need to enable this innovation. So that's another session of my presentation over about the innovation, the cycle, etc. And if I just put that back now onto our work program, in the master plan for ATM, you will find description of 3 phases of change: time-based, trajectory-based, and performance-based operations, of which there are lots of enablers and change sitting underneath that. The SESAR program really tackles that portion in that it is very much concentrating on the earlier time frame and looking out towards the future. And then Work Package E adds to that and looks at the higher service levels and longer out in time. And then things coming from our long-term research that have the potential for earlier inclusion within our program can become applications into the SESAR development program. So it just shows how we can join Work Package E and your work into the program, and again supporting this continuum of change in innovation in the ATM sector. So the SJU has an operating life to the end of 2016, but we're creating a program of work that can continue beyond our current lifetime. And that applies equally to the development program that needs more information fed into it, and very much is one of our focuses for the long-term and innovative research. We want to leave at 2016, let's assume that there is no more SJU, we want to leave a legacy which becomes the next start point for another program of work in ATM, much as the previous research has formulated the SESAR development program of today. So we want to leave that legacy. So you are part of generating that next step, that next evolution. So that's a message I wanted to pass. So, Work Package E. How are we doing for time? Right, okay. So I brought, knowing that it's 45 minutes, I brought plenty of information and also knew that I'd run out of time. but and I know I need to speed up, so I'm going to skip over some slides. This just shows you currently what Work Package E contains as per the call that was made the beginning of June. So 5 thematic areas. Some of them are consistent from today's theme, some of them are new, but in particular, towards high level of automation in ATM is a theme that has been in the program from the beginning and is still there. I won't go into the others, but just note this is the sort of scope of our thematic program today and the desired scope of our long-term and innovative research. It also will complement other research activities being performed by other organisations, including the European Commission, from their research area, for example, and we regularly exchange information with them so we complement the two programme activities. There is some fit between what's called by research, for example, DG Research, and what's called by us. So we work together to try and ensure there's a good cooperation. So, mindful of time, I will skip this one and move straight into about some information. I'll skip through some of these quite quickly. These are slides that came directly from one of our networks, and it's the network which is on the automation, and it's called HALA, and it's a network you should be aware of in your work because they concentrate on the state of the art in automation and developing that state of the art. And for me, this is a repository body of knowledge for you doing your work in supporting automation from a legal perspective. This is their summary. They're going beyond the traditional approaches. They're really looking out into the future. They're promoting research, and they're going beyond what we've currently got in the SESAR program. One of the key elements to point out is they have a position paper, this bottom box, which describes the research, the state of the art. It's meant for other researchers to access as a body of knowledge in automation, and they maintain it, and it's one of the key roles of the network. So I would ask you to go to their website and actually have a look at that position paper. Some of you may already be members of the network and know something about that. Great, but keep the knowledge flowing amongst you. It's a very good source of information on automation in ATM. They have already identified a number of the other Work Package E projects which are naturally associated to their network, and these are the titles. You'll find a short description of each of those if you go to the SESAR website. So the address is at the end, but you can imagine it's sesarju.eu. But the address is at the end. You'll find a short description of each of these, what they're doing. And these are the projects they see as being core relationship for them. Just a point of note, ALIAS isn't there. Is that something you need to address? Do you want to be an associated project with an automation network? I think perhaps you do. Yeah. So maybe next time I see them present this slide, you're on there. So just a thought. This is their take on my program slide earlier, where they were emphasizing that they really understand this core development work, long-term research, and then bringing the ideas back, and they're very much into knowledge transfer and the innovation flow. This is what they have currently in the content of their position paper, but it does evolve over time, so it's not a static document. And one of the key things they're looking at here in automation is the role assignment for the human. The best time, decision place, and best player are the three things that they are really exploring to understand how the human and the machine interact in the best way. What's the best way to actually fit the automation around the human role? So again, that's something that you can get much more information on from their position paper. This is talking about just the shift from controller-based to more automation. They are recognizing that humans will still constitute a core of the future system, but what they're not doing is constraining where they are in that core. They're opening the doors to a whole new role. So this is just exploring some of the areas in their paper, just summarizes some of the key points from their paper. So I'll skip over these very quickly because you can read about them in more detail. This really goes a little bit further into this best time, decision place, and best player that they're really focusing on. And again, this really takes that another step further. Again, these slides will be available afterwards, there's no problem, so you can read them in more detail, but this information is on the HALA website and also in their position paper. So this is the scope of their work, the relevance. So they are looking at trajectory management, as are many other players. They're looking at taking trajectory management beyond where we are in the program. Decision support, control system techniques, human factors, and UAS. And they're using UAS often as a means of demonstrating future automation roles. So they're making some links to UAS-based projects where future roles are explored using those kinds of systems. This is the set of PhDs that they're working on, and I won't read these at all, but they do manage or supervise a set of PhDs which are relevant to the automation. They're managed by, they're hosted by a number of universities, but there are 13, I think it is, PhDs that are relevant to the HALA automation network coming from various universities. So, very quick summary, as I'm mindful of time. From the SJU, our objective is to implement this healthy body of research. That's what we want. That's what we're trying to facilitate with all the work that we've been doing to set this sort of the networks, the projects, and everything up. We really want that healthy body of research, repository of knowledge. We want to improve the communication across research areas by ensuring that there are events during the year that are centered on communication, including the Innovation Days, which runs every year now. Started last year in Toulouse. This year it's at Braunschweig, thank you. I was trying to get my tongue around it, in Braunschweig in November. And it's an opportunity for everybody within Work Package E and invited guests from outside to come and talk about their research, their work in innovation, their lessons, their experiences, and really network together. And with our scientific committee, who supports our work within the joint undertaking, we're also developing the ideas of introducing a Young Scientists Award, so look out for that, and also a Science and Innovation Award across Work Package E. So we want to put some recognition back in to the work that's being done as well, some recognition about strong achievements, really good achievements, good ways of working. So we're developing that idea too, and you'll see some more information on that. And this is the slide that I'll finish with. And it just starts to then join my discussion about the work programme, our work programme, and Work Package E and its position just tries to show you how it all fits together. And if I take a range across the horizontal axis here from highly innovative work through to full industrialization and deployment, so that's the scale across here. And I've got a freedom axis here, which is high degrees of freedom to do things as you want, when you want, and a methodology-based approach, a full formal system engineering type of approach. You can imagine sort of what I'm going to do now, but say, well, actually the exploratory research and the ideas sits down here. The deployment results sits up there. And we think work package E is kind of just into this area where you're really starting to generate the understanding of some of these ideas that have been around for a while, but really generate that understanding. There may be some element down here, but essentially we're building a route through here to deployment results. And you will see us being much more relaxed about the way things are done here. I know some of the people here are very familiar with our work program, so you'll see us being much more controlling, perhaps is a word, as we start getting up here, because we have to be rigorous about how we get out to here. So it just shows that we have an understanding of how we're joining all of this together, but it does leave one of those quadrants kind of empty, and the only thing I could say about that was, well, if we end up in there, we're in a mess, and I don't intend to go there. So with this slide, I will finish. I will thank you for your attention. And I would invite any questions, but I don't want to keep you from your break, because I know that's coming up next.
No, I would like to thank you.